Hello everyone, welcome you all back to my YouTube channel Study with Tej. I'm Dr. Tejashwini N. As we have already dealt with protocol layering in the previous video, today let's discuss about TCP IP Protocol Suite, Encapsulation and Decapsulation, Multiplexing and Demultiplexing, OSI and OSI versus TCP. So basically TCP IP Protocol Suite is an hierarchy protocol made up of interactive modules where each module provides a specific functionality. We have five layers here. That is, if you this model basically defines how the data has to be transported over the networks, ensuring the reliability of communication between the devices. Then this layer has five. This model has five layers. That is, application layer, transport layer, network layer, data link layer, and physical layer. And the two important protocols are TCP and IP here. Let's see the diagram. Here, let's assume computer A wants to communicate with computer B. Here we have five communicating devices. That is the source, the destination, and links, three links, link 1, 2, and 3. Here it is separate. You can notice that I'll be telling. So it is A and B, and there are three links. Link 1 and 2 is switches, and link 3 is router. In the source and the destination, there are five layers, whereas in link 1 and 2, that is switches, it is only two layers, and with link 3, that is router, it is three layers. So, as the router is the only used for routing, it only has three layers. Even though router works at the network layer, still it is involved in n combinations of the link and physical layer both. Here, n is the number of links that the router in that whole how it is connected in the connection. So, if there are n connections, then it will have n number of links. This is because each link shall use its own data link layer and or physical layer protocol. That is the reason this is being separated. If you can see here, so router has this is how it is being differentiated. Here it is using a separate set of here it is using a separate set of protocol, and here it is using a separate set of protocol. So that is what I am trying to tell you. And here as in the example, so only links two links it has, so it has been divided into that set of protocols here. So routers may receive the packet from link 1 based on the pair of protocols and deliver it to the link 2 based on that another set of protocol. When it comes to switches, they only have two layers and use only one set of protocols, not like your router wherein they are using different set of protocol at different links. They are using same set of protocol. Next, we shall discuss the layers in TCP IP protocol suite and their functionality. We have already discussed the logical connection which makes the understanding of these layers easy. The first top three layers, application, transport, and networks layer, are end to end, and bottom two layers are that is link layer and the physical layer are hop to hop. As said earlier, the objects at the layer is identical, where the objects at the top three layers are not changed by either router or switches, but the objects are changed by the router and not switches in the bottom two layers. Now it's time to understand how each layer work. The lowest layer of TCP IP model architecture is the physical layer, and it is basically responsible for carrying individual bits in the frame across the link. This is basically made of transmission media like cable or air. As we know, The transmission is carried through electrical signals or optical signals. The logical unit is bit in this layer. Next, coming to the data link layer. Basically, there may be several overlapping sets of link at the datagram can travel from host to destination. Here, it is responsible for moving the frame through the link. The function carried out by this layer are encapsulation of the datagram into the frames that has been transmitted by the network and mapping the logical address to the physical address. Logical addresses are nothing but the IP address, and the physical address is nothing but the MAC address. And this will define how the data should be sent physically through the network. So basically, these two layers are responsible for transmission of data between any two devices on the same network. So the link can be either the wired with the link layer switch, or a wireless LAN, or a wired WAN, or a wireless WAN. This TCP IP is not specific on protocol used in data link layer, as it supports the standard and proprietary protocols. Any protocol that has been capable of carrying the datagram through the link is sufficient for the network layer. The data link layer encapsulates the datagram into a frame. So, some link layer protocols provide complete error detection and correction, and some provide just the error correction. Now, let's get into network layer. Here, this is the third layer of the TCP IP model, and the communication at the network layer is host to host communication, and routing is also mainly done at network layer only. Network layer will create the connection between the source and the destination computer. Here, the communication is host to host. A router in the path are responsible for choosing the best route for each packet. So it is the layer where it will send the packets from any network and they arrive at the destination taking the shortest path for routing. And it adds the IP address to the TCP segments to form the IP packets and uses the same has been used by the routers to send IP packets to other networks. One of the main protocol here is IP, that is Internet Protocol, and few are ARP, ICMP, all those things. So let's get into what IP is basically. It is a connectionless protocol wherein it is not providing any flow control or error control or congestion control services. It defines the basically it is all about it is a connectionless protocol when no flow control, error control, or congestion control is given. If at all we need any of these uh, thing to work, services to work, then you have to depend on the transport layer protocol. And there are few routing protocol for unicasting and multicasting, but these do not take part in routing. Instead, they are there for creating the forwarding tables for routers and help them in routing process. To basically the responsibilities are IP addressing, host-to-host communication, routing, and data encapsulation and formatting. Wherein in IP addressing, the logical addresses known as IP addresses are being implemented, and it will deliver the packet from source to destination following that IP address. And host to host communication is the path through which the data has to be transmitted. And encapsulation is the IP protocol will accept the data from the transport layer protocol and it encapsulates into a datagram called as IP datagram. So there are few protocols that helps the IP to perform better, to deliver and routing process to help them. There are few protocols like ICMP, IGMP, DHCP, ARP, etc. So let's learn everything in detail. Basically, IGMP is Internet Group Management Protocol, which helps in multitasking, and ARP stands for Address Resolution Protocol. Here, The main functionality of ERP is to find the physical address from the logical address. That is physical address from the IP address or logical address. And the functionality of ICMP, that is Internet Control Message Protocol, is to basically find the problem, that is to notify regarding the packet problems that can be sent back to the host or the sender using this. That is, you'll go tell the sender or the user that there was an error or a problem and the packets were not delivered. Once they get to know any such issue is there in the network, that will be immediately notified to the user by ICMP, and it can only inform the user about the errors, but it cannot rectify that errors. So this is the main functionality of ICMP. So before that, I would also like to tell you DHCP, which is again a part of IP protocol only, which helps it. Dynamic host configuration protocol. It helps the IP to get the network layer address for the host. And next is transport layer protocol. Basically, it is the fourth layer, and it is responsible for giving the services to the application layer, as in which any lower layer will be giving providing the services to the higher layers. The transport layer is responsible for segmenting, flow control, and the correction of data which has been sent over the network. So here it gives all as which network layer didn't give. It gives everything, that is flow control, error control, and congestion control. The basically two important protocol used here is UDP and TCP. Let me first talk about TCP. TCP is the main protocol which is connection oriented protocol. It establishes the logical connection between two hosts before transferring the data. It provides all the three services, that is flow control, error control, and congestion control. Whereas in UDP is a connectionless protocol and it does not provide flow control, error control, and congestion control. We also have Stream Control Transmission Protocol (SCTP) for applications that use multimedia. So this is all about that. So basically, as I have said earlier, this is one which will be providing all the three services. Okay, and it creates a virtual circuit between the sender and the receiver. As I've said, it is connection oriented, so it will create the virtual circuit between the sender and the receiver, and it is active for the duration for transmission. At the sending end, TCP will divide the whole message into smaller units known as segments, and each segment contains a sequence number which is required for reordering. Once you send and that has been not received in the order at the receiver end, for reordering purpose, this particular sequence number is helpful. So TCP/IP is a reliable protocol because it's a connection oriented and it is setting up a virtual circuit. It is a reliable protocol and it detects the error and retransmits the damaged frames. Once there is any problem with the frames, it will be transmitting the damaged frames. Therefore, it ensures all the segments must be received and acknowledged before the transmission is considered to be complete. And after all these things have been done, the virtual circuit is been discarded. At the receiving end, TCP collects all the segments and reorders them based on the sequence number. It provides, as I said, all the three flow, error, and congestion control. Next, coming to application layer. Here also the logical connection is end to end. Process to process communication shall happen here. So here this layer also needs so many protocols like HTTP, SMTP, FTP, Telnet, SNMP, all those things. So Telnet and Secure Shell are used to access this site remotely. Whereas HTTP stands for Hypertext Protocol, this protocol allows us to access the data over the internet. That is all your web pages. If you have seen HTTP and HTTPS, that is how it starts. So accessing all your web pages is done through this protocol only. It transfers the data in the form of plain text, audio, video, etc. Then SNMP stands for Simple Network Management Protocol. Basically, it is used to administer to manage internet at the global and local levels. SMTP stands for Simple Mail Protocol. Basically, all your email services are being taken care of this protocol. DNS stands for Domain Name System. It is used for by the other protocol to find the network layer address of a computer. FTP is File Transfer Protocol, and it is used to transmit the files from one computer to another computer. So let's see what is encapsulation and decapsulation. Basically, encapsulation, if you see here in the source, and if you can just see here, initially the application has given only the message, and later from transport layer till physical layer, it has been adding something, that is some headers and trailers are being added. So the process of adding the headers and trailers around the data that has been sent is basically encapsulation. At the application layer, if you can see, data to be exchanged is called message, and it does not contain any header or trailer, and this message is passed to the transport layer. At the transport layer, it takes the message as payload, and it will add the header and other information. This results in a packet. Then it passes that packet to the network layer. Network layer will add its own header and necessary information in the result, resulting in the datagram, and this datagram is being passed to the data link layer. Again, at the data link layer, on it will add its own address, header and trailer. So it will add own address to the packet, and resulting that in the resultant is called as frames, and that is being passed to the physical layer for transmission. So then, what happens in decapsulation is nothing but it is a reverse process of encapsulation. If you can just see here in the any of these two diagram, both diagram are same. See, if you see here, at this layer, one is removed and the rest is passed. So this is what is actually decapsulation is all about. Reverse process of encapsulation that occurs when the data is received at the destination computer. At the router, we have both encapsulation and decapsulation. A data link layer receives a set of bits. It decapsulates the frame into datagram and passes to the network layer. And the network layer also inspects for source and the destination address and consults its forwarding table to help the next hop. And after removing it, the datagram is passed to the data. The datagram is passed to the data link layer for the next link. The data link layer, it should be the other way. uh, Once whatever is passed at the network layer, it is passed to the transport layer. Again, uh, header and the trailer information is clipped off, and it is passed to the application layer. So it is just a reverse process of encapsulation. So all the headers and trailers are removed, and only the payload is being given to the application layer. What is kind of addresses at each layer? At application, it is application specific address, and transport layer, it is port address. Network layer, it is logical address. Data link layer, it is physical address. So these are how the addressing is being done. Addressing scheme that allows the users and application to identify a specific network or host with which it communicates. So this is how it has been done. Next, coming to multiplexing and demultiplexing. Here, the TCP IP protocol suits uses several protocols at some layer. We have multiplexing at source and demultiplexing at the destination. Multiplexing means a protocol at the layer can encapsulate a packet from several next higher layer protocols, and demultiplexing means this protocol can decapsulate and send the packets to several next higher layer protocols. Coming to OSI, it stands for Open System Interconnection. Basically, this is a reference model that will describe how to facilitate communication between different systems without requiring any changes to the logic of the underlying hardware or software. Basically, this was developed by ISO, that is International Organization of Standardization, in 1984, and now it is considered as an architectural model for computer communications, and it contains 7 layers. TCP/IP had basically 5 layers. In other searches, you might also see it as 4 layer, wherein data link layer and physical layer is clubbed into a layer called network access layer. So 4 or 5 layers, but whereas here it is 7 layers. Each layer perform a particular network function. It divides the whole task into 7 smaller and manageable tasks. Each layer is assigned a particular task. Each layer is self-contained, and so that the task assigned to each layer can be performed independently. So these are the same: physical layer, data link layer, network layer, transport layer, and application layer remains the same. Two extra layers here is session layer and the presentation layer. If you can see the functionality here in the diagram, the application layer provide the services to the user, and the presentation is layer is responsible for translation and compressions, encryptions, all those things. It also will take care of the semantics and the syntax of the communication. And a session is used to establish and manage the sessions and also terminate the sessions. And transport layer, as usual, it is provides a reliable message delivery from process to process, and network is responsible for routing, especially from source to destination. Data link layer is for error control and flow control, and physical layer is one which actually has a transmission medium through which the data has been transmitted. So each layer are related, and each of which defines a part of process of moving the information across the network. So if we differentiate OSI versus TCP, the big difference between these two models is that this has 7 layers OSI instead of 5. Although both TCP and IP models transport the data, the way they send it are slightly different. The session and the presentation layer are separate in OSI, but whereas in TCP they are not. TCP model In TCP/IP model, the transport layer has more than one protocol, so some functions of session layer are available in some transport layer protocol itself. Thank you for watching. For all the informations on data communication and computer networks, keep watching Study with this. Thank you.